Good morning. This is Unit 3, Day 7. We're going to go over this first question. It says, in this question, distances are measured in meters and velocities in meters per second. A submarine is rising to the surface of the sea in a straight path. At time t equals 0, the submarine is at point P with the coordinates 350, -217, and 785 relative to a set of axes whose origin 0 lies at the surface of the sea. The x-axis is due north, so I drew the x-axis, and I'm going to make this one is the one due north. This is my x-axis, so I'm going to put north next to it, so remember. And the y-axis is vertically upward, so I drew it this way so we can kind of see that this is up, so I made it dotted. This is my y-axis, and this is up. And the z-axis is due east, so I drew it to the right. The velocity of the submarine is given by the vector -9I plus 7J minus 4K. Make sure they're written in the right order. This one is. Write down the position vector of O to P. Well, O to P, is just P minus O, and my position vector O to P is just going to equal 350, -217, and 785. Find the speed of the submarine. The speed is going to be the magnitude of the velocity vector. Oops. Okay, well, they give us the velocity vector. For magnitude, we use that formula. So my velocity vector, the magnitude of my velocity vector, equals the square root of, and then x squared, -9 squared, remember this is always going to become positive, plus y squared, which is 7 squared, plus z squared, which is -4 squared. I would just plug this into your calculator. I did this. Make sure that you put the parentheses around them and they're positive, and you get something like 12.08. Let's just say 12.1, and it says that the velocity is in meters per second. So I'm going to put 12.1 meters per second. The submarine's path can be modeled by a straight line. Find, in terms of t, the vector equation of this line. So my vector equation is something that we did on our test, on our last quiz. So we know that this is x, y, z. We have three variables, x, y, z, equals, and my position vector, which they gave us, my initial position, which I'm going to say is 350, -217, and 785, plus t times the directional vector, which is going to be -9, 7, and -4. That is my vector equation of the line. A stationary fishing boat is located at point Q with these coordinates. How far, the distance, is the submarine from the fishing boat when it surfaces? So when it surfaces, we're not down or up, we're exactly on the water. So on top of the water. So this is when our y values equal 0. So I can actually solve for t very easily when y is 0 by just using my y equation. So when y is 0, 0 equals, and then we have negative 217 is my y position, plus t times negative 9. So if I move this 217 to the left-hand side, I get a positive 217 equals negative 9t. If I divide by negative 9, 217 divided by 9 is going to give me, sorry guys, I needed to use the y one. So this is my y, and then this is my y. So this is supposed to be 7. And this is supposed to be 7. Now it's positive 7 t. So 217 divided by 7 gives us 31. So when our time is 31 seconds, we're talking about seconds. Okay, this is when at this time is when our subsurface is. So we can plug it in to find our x value and our y and our z value. So what we're going to do is just plug it in for x. We know that x equals 350 plus negative 9t. And we can plug in t, substitute t, and we have 3x equals 350 minus 9 times our t is 31 seconds. And this is when our x is at 71. Let's do the same thing for z. Z equals 785 plus t times negative 4. So 785 minus 4t. And we know that we want to find out when t is 31 seconds. So 785 minus 4 times 31 seconds is 661. So my z value equals 661. So my point, my position, or my point when my subsurface is going to be 71. Of course, y is 0. And then my z is 661. 71, 0, 661. And we know that we're given q is 10, 0, and 600. Now it says, how far is a submarine from the fishing boat? Well, we're going to have to use our distance formula. So first, let's find P to Q. Remember that is Q minus P. P to Q is Q minus P. So I'm going to do Q minus P, which is 10, 0, 600 minus P, which is 71, 0, 661. And this gives me negative 61, 0, and negative 61. Okay. This is P to Q. Now we're just going to find the magnitude of this P to Q. The magnitude of P to Q is the square root of negative 61 squared plus, we can just put 0 squared, that's fine, plus negative 61 squared, which is equal to, check it, but I think we got 86.3 meters. So this is the distance between my sub and the fishing boat. Alrighty guys, this is going to be all for today. Have a wonderful day, and if you have any questions, ask me.